Let's explore. Number 10. The Methuselah Star. In the constellation Libra, approximately 190 light-years from Earth, there is a star that should not exist. Its official designation is HD 140283. Astronomers call it the Methuselah Star, and the reason they gave it that name is the reason it has been quietly terrifying astrophysicists for 2 decades. It appears to be older than the universe itself. To understand why this is not merely a curiosity, but a genuine crisis, you have to understand what the age of the universe actually means in physics. The Planck Space Telescope's measurements of the cosmic microwave background radiation give us the age of the universe with extraordinary precision, 13.8 billion years. This is not an estimate with wide error bars. This is one of the most precisely determined numbers in all of science, and it represents an absolute logical boundary. Nothing in the universe can be older than the universe. A child cannot be born before its mother exists. Effect cannot precede cause. This is not a rule that physics allows exceptions to. It is the rule that physics is built on. HD 140283 does not appear to have received this message. This star is a subgiant racing through our galactic neighborhood at 800,000 miles per hour. A velocity so extreme it marks it as a relic from the earliest epoch of the galaxy. Its composition tells the same story. It is made almost entirely of hydrogen and helium, with virtually no iron, no oxygen, no heavy elements whatsoever. Heavy elements are forged inside stars and scattered by supernovae, a star with almost none of them formed, before most stars had lived and died. When astronomers calculated its age in the year 2000, they arrived at 16 billion years, 2 billion years older than the universe that supposedly contains it. The scientific community did not accept this quietly. In 2013, the Hubble Space Telescope was deployed specifically to revisit the measurement. The revised age came back at 14.46 billion years, more precise, still older than the universe. The only way physicists can sleep at night is by applying an 800 million year uncertainty margin, but the tension has never gone away. This star sits in our cosmic neighborhood, burning with a quiet, steady light, and what it implies does not fit inside either of the two acceptable outcomes. Either our understanding of stellar evolution contains a fundamental error we have not yet identified, or the age of the universe itself is wrong. And if the universe is older than 13.8 billion years, everything we think we know about what happened between the Big Bang and now has to be rebuilt from the beginning. Number 9. The Hercules-Corona Borealis Great Wall. One of the foundational assumptions of modern cosmology is called the cosmological principle. It states that on a large enough scale, the universe is smooth. Matter is distributed evenly. No region is dramatically denser or emptier than any other. This principle is not decoration. It is the mathematical bedrock on which every cosmological simulation, every dark matter model, every calculation about the structure of the cosmos is built. There is a hard limit on how large any gravitationally assembled structure can be, because structures form by gravity pulling matter together over time, and there has only been 13.8 billion years for that process to operate. The calculations are unambiguous. No structure in the universe should be larger than approximately 1.2 billion light-years across. Anything bigger simply could not have had enough time to assemble. In 2013, astronomers mapping the distribution of gamma-ray bursts discovered a filament of galaxies that is not 1.2 billion light-years wide. It is 10 billion light-years wide. This is the Hercules-Corona Borealis Great Wall. It spans more than 10% of the entire observable universe. If you traveled at the speed of light, it would take you 10 billion years to cross it. Essentially the entire current lifespan of the universe, just to get from one side to the other. Its existence is a direct structural violation of the cosmological principle. Our simulations of dark matter and gravity, run on the most powerful computers we have, cannot produce a structure of this magnitude in the time available. It is like finding a fully grown oak tree 5 minutes after planting the acorn. Not a sapling, a fully grown tree with centuries of rings. The Great Wall should not be there. It does not fit. Number 8. Hoag's object. Galaxy formation is a violent, chaotic process. Galaxies collide, merge, shred each other with tidal forces, and slowly settle into recognizable shapes through billions of years of gravitational negotiation. We understand spiral galaxies. We understand elliptical galaxies. And then there is Hoag's object, discovered in 1950, which does not fit into any of those models, and has not fit into any of them for 75 years. Hoag's object is a perfect ring galaxy. At its center sits a compact sphere of old yellow stars, billions of ancient suns. Surrounding this central sphere, separated from it by a gap of almost perfectly empty space 70,000 light-years wide, is a vast ring of young blue stars. Not a spiral, not an ellipse. A geometrically precise ring completely detached from the core it encircles. It looks, with an accuracy that becomes more unsettling the longer you look at it, like a cosmic eye staring back at you from the darkness. The standard mechanism for ring galaxy formation requires a collision. But if this happened to Hoag's object, the impacting galaxy has vanished entirely. There is no second galaxy in the vicinity. There is no debris field. There is no gravitational trace of anything that could have produced this structure. It is a galaxy with no visible past and no discoverable origin. And if you look closely at the gap between the ring and the core at the 1 o'clock position, you can see another ring, galaxy in the far distance, perfectly aligned within the first one. A ring within a ring. Number 7. The CMB cold spot. When we observe the cosmic microwave background, the thermal afterglow of the Big Bang, the oldest light in the universe, we see a nearly perfect sphere of faint radiation, encoding in its temperature variations the distribution of matter in the infant universe. These variations are tiny, and according to the physics of inflation, they should be essentially random. Except for one. In the southern hemisphere of the sky, there is a region approximately 1 billion light-years across that is significantly colder than everything surrounding it, 70 microkelvins colder than the average temperature of the CMB. According to standard inflationary cosmology, the probability of a fluctuation this large and this cold arising by random chance is less than 1.85%, essentially impossible. Astronomers tried to explain it as a supervoid. But analysis in 2017 demonstrated that there are not enough voids in that direction to account for the temperature deficit. The math does not add up. This leaves theoretical physicist Laura Mersini-Houghton's proposal as the most coherent surviving explanation, and it is the most disturbing theory in observational cosmology. The cold spot is a bruise. It is the scar left on the fabric of our universe by a collision with another universe. If our cosmos is one bubble in a vast multiverse, billions of years ago, another bubble universe collided with ours, leaving a permanent scar on the fabric of space-time that we see today as the cold spot. What we are looking at might be the first direct physical evidence that something exists outside our universe. Number 6. The impossible early galaxies. In 2023, the James Webb Space Telescope turned its gaze toward the earliest epoch of cosmic history, looking back to just 500 to 700 million years after the Big Bang. The expectation was clear and well-founded. At that age, the universe should be full of proto-galaxies, small, messy, dim collections of gas in the early stages of collapsing under gravity, only beginning to form their first stars. Astronomers expected a nursery. They found adults. The James Webb Space Telescope discovered 6 massive, fully formed galaxies at this epoch that contain as much stellar mass as our own Milky Way, up to 100 billion solar masses, existing at a time when the universe was less than 3% of its current age. The scientific community's response was to call them universe breakers, because that is precisely what they do. According to the standard cosmological model, there was not enough normal matter in the early universe to have assembled into galaxies of this size this quickly. For these galaxies to exist 500 million years after the Big Bang, they would have had to convert nearly 100% of all available gas into stars instantaneously, with zero inefficiency and zero regulatory feedback, violating every physical limit on star formation that we have ever measured or modeled. Their existence does not merely challenge the standard model. It implies that the timeline of the universe is fundamentally wrong. We are looking at fully grown adults in a cosmic nursery, and we do not know how they got there, and we do not know what we have been missing. These galaxies existed before our models say they could have. They are massive beyond what the physics of that era permits. And the telescope that found them is still running, still looking deeper, and still finding more of them. Number 5. The OMG particle. Space is not perfectly empty. Even in the darkest, most remote regions between galaxies, the universe is filled with a faint bath of photons, the leftover glow of the Big Bang, spread evenly across all of space at a temperature just above absolute zero. This photon background has one critical consequence for high-energy particles traveling through it. There is a speed limit. If a cosmic ray travels above a specific energy threshold known as the GZK limit, it will collide with these background photons, lose energy, and slow down before it can travel very far. No cosmic ray originating from deep space should arrive at Earth with energy significantly above the GZK limit. It is physically impossible. The particle would not survive the journey at that energy. On the 15th of October, 1991, the Fly's Eye Cosmic Ray Detector in Utah registered a single proton, striking Earth's upper atmosphere with an energy 8 times above the GZK limit. They called it the Oh My God particle, and the name was not an exaggeration. This particle was traveling at 99.999999999 or 99999999995, 1% of the speed of light. If this particle had raced a beam of light across the entire diameter of the Milky Way galaxy, the light would have arrived first, by only a few centimeters. Something invisible in the darkness is firing subatomic particles at us with energies that should be impossible. We do not know what it is, we just know the detector readings are real. Number 4. Tabby star. Stars are predictable. A star shines at a constant brightness determined by its mass and age. When a planet passes in front of it, the star's light dims by a fraction of a percent, typically less than 1% for even a large planet, for a few hours, in a perfectly regular, perfectly periodic pattern. This is how we find planets. It is reliable, well understood, and boring in the best possible way. KIC 8462852, known as Tabby star, is not boring. It dims by up to 22%. In single events, irregularly. For durations ranging from days to weeks, with an asymmetrical profile that matches no known physical process in stellar astrophysics. To block 22% of a star's light, you need an object roughly half the diameter of the star itself. No planet is half the diameter of its star. No natural object orbits its star in the irregular, aperiodic pattern that Tabby star's dimming events show. Every natural explanation has been tested against the data and eliminated. Comets were proposed. You would need hundreds of thousands of giant comets, all simultaneously aligned, statistically absurd. Dust was proposed. Tabby star shows no excess infrared signature. Dust is not there. This forced the scientific community to formally consider what is now referred to in the published literature as the forbidden hypothesis, a Dyson sphere under construction. Physicist Freeman Dyson proposed in 1960 that any sufficiently advanced civilization would eventually build a structure around its star to capture its total energy output. A megastructure of solar panels, habitats, and energy collectors surrounding the star in a partial or complete shell. If such a structure were being assembled, it would look exactly like Tabby star. Massive irregular panels blocking large, asymmetric chunks of starlight with no thermal infrared signature because they are engineered surfaces, not dust. Tabby star looks with an accuracy that is difficult to dismiss, like someone taking apart a solar system to build a machine. Number 3. The dark flow. The expansion of the universe is one of the most well-established facts in cosmology. Every galaxy cluster is moving away from every other galaxy cluster, carried apart by the expansion of space itself, the Hubble flow, uniform in all directions. Within this flow, individual galaxy clusters have small peculiar velocities caused by the gravitational pull of nearby mass concentrations. These peculiar velocities are local. They are random in direction. They cancel out statistically when you look at large enough samples. In 2008, a team of astronomers analyzing the peculiar velocities of hundreds of galaxy clusters found something that does not cancel out. Hundreds of massive galaxy clusters, spread across a vast region of the sky, are all streaming in the same direction at 2 million miles per hour. Not randomly, not locally, in the same direction, toward a specific patch of sky between the constellations Centaurus and Vela, with a coherence that extends across distances too large to be explained by any mass concentration within the observable universe. They called it the dark flow. The Great Attractor was considered as the source. The dark flow moves straight through the Great Attractor and keeps going as if it is not even there. The source of this gravitational pull is not inside the observable universe. The observable universe is a sphere approximately 92 billion light-years in diameter, We cannot see past its edge. But the dark flow suggests that beyond that edge there is something so massive that its gravity reaches across the boundary and pulls hundreds of our galaxy clusters toward it at 2 million miles per hour. We are being pulled by something we cannot see, cannot reach, and cannot ever observe directly. Number 2. The Vacuum Catastrophe. This is the entry that physicists most often cite when asked to name the single greatest unsolved problem in theoretical physics. The reason is not that it describes something we do not understand. The reason is that it describes something our two best theories predict with complete internal consistency, and whose predictions disagree with each other by a factor of 10 to the power of 120. Quantum field theory tells us that empty space is not empty. Even in a perfect vacuum, the Heisenberg uncertainty principle requires that space seethes with virtual particles constantly flickering in and out of existence, producing a background energy density called the vacuum energy. This is not theoretical speculation. The physical effects of vacuum energy have been measured in laboratories and confirmed to extraordinary precision. The vacuum energy is real. General relativity tells us that energy gravitates, so the vacuum energy of empty space should act as a cosmological constant, driving the expansion or contraction of the universe. So physicists calculated the vacuum energy from quantum field theory and compared it to the observed expansion of the universe. The theoretical prediction is 10 to the power of 120 times larger than the observed value, not 10 times larger, not a million times larger. 10 to the 120th power times larger. If you tried to estimate the diameter of the entire observable universe, and your answer was off by the diameter of a single proton, your estimate would still be billions of times more accurate than this calculation. According to our best quantum physics, the energy density of empty space should be so enormous that the universe should have torn itself apart in the first fraction of a microsecond after the Big Bang. The fact that we are here, that atoms formed, that stars ignited, that galaxies assembled, that you exist, is, according to the numbers, a violation of the physics we use to describe it. Something is canceling almost all of the vacuum energy to within 1 part in 10 to the 120th. We do not know what. We do not know why. We do not have a theory that predicts or explains it. The two greatest frameworks in the history of physics look at the same empty cup of space and disagree about its energy content by the largest factor ever recorded in science. Either our understanding of the very small is broken, or our understanding of gravity is broken. The two pillars of physics are fundamentally incompatible. And the fact that the universe exists at all is, according to our own best mathematics, something that should not have happened. Number 1. Boltzmann brains. Everything in this video. The star older than the universe, the structure too large to exist, the galaxies that formed too fast, the particle that traveled too far, the star that dims impossibly, the flow toward an invisible attractor, the vacuum energy that should have destroyed everything. All of it is disturbing because it suggests our understanding of physics is incomplete. But this last entry is different. This one is disturbing because it suggests that you might not be real. The second law of thermodynamics tells us that the universe tends toward disorder. Entropy increases. Complex ordered structures over galaxies, stars, planets, living organisms, conscious minds, are extraordinarily improbable arrangements of matter that form only because local decreases in entropy are driven by energy flowing from hot regions to cold ones. In a universe that expands forever and eventually reaches maximum entropy, all structure will dissolve. But quantum fluctuations never fully stop. Even in a state of maximum entropy, the void will occasionally, randomly, produce a spontaneous fluctuation, a temporary local decrease in entropy, a brief arrangement of particles into something more ordered than their surroundings. And here is where the physics becomes genuinely nauseating. The probability of a random quantum fluctuation producing a single isolated brain, complete with fully formed sensory organs, a nervous system, and a set of false memories, encoding an entire lived experience, is incomprehensibly small, but it is vastly, exponentially, incomparably larger than the probability of a random quantum fluctuation producing an entire universe with billions of years of consistent history, hundreds of billions of galaxies, and billions of biological organisms who evolved over geological timescales. In a universe that lasts long enough, the number of Boltzmann brains, disembodied conscious minds that fluctuate briefly into existence in the void with false memories of a life that never happened, will vastly outnumber the biological brains that evolved on planets. The math is not ambiguous. If the universe is eternal, statistical physics predicts that you are almost certainly not a biological human who evolved on a planet with a 4 billion year history. You are almost certainly a momentary fluctuation in the vacuum, a brain that condensed from random quantum noise 1 second ago, complete with false memories of everything you believe you have experienced, and that will dissolve back into the void 1 second from now. The fact that you appear to be experiencing a coherent, consistent reality right now is not evidence against this. A Boltzmann brain would experience exactly what you are experiencing, and would be convinced of its own reality with exactly the conviction you currently feel. The only way out of this conclusion is to show that the universe is not eternal, that it will end before enough time passes for Boltzmann brains to dominate the population of conscious minds. But the evidence currently suggests the universe will expand forever, driven by dark energy that shows no sign of weakening. Every year the universe continues expanding. The Boltzmann brain problem gets worse. The math does not resolve. It accumulates. From the Methuselah Star to the Boltzmann brain, every anomaly in this video is a crack in the glass. Each one is a place where the universe whispers that our rules are suggestions, that the true nature of reality is stranger and darker than anything we have managed to understand. The Methuselah Star tells us our timeline might be wrong. The Great Wall tells us our models of structure formation are broken. Hoag's object tells us that geometrically perfect structures can form by mechanisms we cannot identify. The CMB cold spot tells us another universe may have physically collided with ours and left a scar we can see. The impossible early galaxies tell us the first chapter of cosmic history has been misread. The OMG particle tells us something invisible is operating at energy scales our physics cannot reach. Tabby's star tells us there is an object in our own galaxy that behaves exactly the way we would expect an alien megastructure under construction to behave, and natural explanations keep failing. The dark flow tells us we are being gravitationally pulled by something outside the observable universe that we will never be able to see. The Vacuum Catastrophe tells us our two best theories of physics are incompatible at a scale that makes the word incompatible sound too mild. And the Boltzmann brain tells us that in a universe old enough and large enough, the statistical argument for your own non-existence as a real biological person is not a philosophical thought experiment. It is a formal prediction of statistical mechanics. The math does not say this might be true. The math says this is almost certainly true. And the only way to argue against it is to show the universe will end before the numbers fully catch up. What unites all 10 of these anomalies is not their individual strangeness. It is what they collectively imply, that the framework we use to describe reality has gaps in it large enough to contain entire categories of phenomena we have not yet named. We did not go looking for any of these things. The Methuselah Star was found while cataloging nearby stars. The Great Wall was found while mapping gamma-ray bursts. The OMG particle arrived without warning on a Tuesday afternoon in October. They arrived as data points that did not fit, as readings that contradicted the models, as objects that sat in the universe quietly being impossible, waiting for us to point our instruments at them and notice. We are not finding the edges of physics by doing ambitious theoretical work at the frontier. We are finding them because the universe keeps producing things that our best theories say cannot be there, and then they are there anyway. This is what makes these 10 anomalies different from ordinary scientific puzzles. An ordinary puzzle exists within the framework. You know what kind of answer you are looking for. You know which equations to apply. These anomalies sit outside the framework. They do not tell us that we need a better answer to an existing question. They tell us we are missing entire questions we have not yet learned to ask. From the Methuselah Star to the Boltzmann brain, these are not failures of science. They are science working exactly as it should, finding the places where the map does not match the territory, marking them honestly, and refusing to pretend the discrepancy is not there. The universe is under no obligation to be comprehensible. It is under no obligation to fit inside the frameworks we have built to describe it. And every one of these 10 anomalies is the universe reminding us, quietly and without urgency, that it was here long before we were, that it will be here long after we are gone, and that the fraction of it we currently understand is very, very small. That was an amazing discovery. If you want to watch more videos like this, don't forget to subscribe, turn on notifications, and like the video. See you in the comments.